Hey everyone, James here from JC Sharp and welcome to the last video in the series of Solid Principles. Today we're going to be taking a closer look at dependency inversion and what that means. As always with all the other videos, there'll be a link in the description to the Solid Principles overview, which I highly recommend you take a look at. Alongside that there'll be the link to the code as well, so that you can grab the code and code along with me. Okay. Dependency inversion then this week. So what is dependency inversion? What does it mean? So dependency inversion has two rules essentially, and those rules are that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions, for example, interfaces. Abstractions should not depend on details, but details should depend on abstractions. I personally sometimes find that sentence a little bit confusing, so perhaps the easiest way to remember it is that low-level objects should be defining contracts for high-level objects to use, so that high-level objects don't need to care about the specific implementations of low-level objects. We're going to look at that example today with a notification type class and sending emails and sending SMSs. So let's have a quick look at the code and then we'll talk about the problems that this presents and how we can solve them with dependency inversion. So we have a notification class, relatively simple. It's responsible for creating a new email and new SMS classes, and then when the send notification method is called, it will send an email and it will send an SMS. And then off the back of that, we have obviously our email and SMS classes with relevant properties and their send email, send SMS methods. So one of the problems that this kind of setup creates is that our notification class is dependent on creating two new classes itself. And what that can mean is that, first of all, we have these potential classes being called when they're not necessary. So we might call send email, send SMS, even though what we really need is just an email. We don't need the message. But as well as that, this kind of setup causes tight coupling between classes. And, in reference to the solid principle, we don't want classes so tightly coupled when they don't need to be. So how do we go about solving this then? So remember, we talked about high-level objects should rely on abstractions of low-level objects. So the first thing we're going to do as part of this is we're going to make our email and our SMS classes inherit from a new interface. And we're going to call that interface iMessage. So let's go ahead and stick that in. Like so. And as part of that iMessage, we're just going to have one simple method that we're going to call public void send message. And that's literally it. That's all we're going to have in there. So straight off the bat, let's get email to inherit from iMessage. We'll fix the problem there. So what we'll do is we'll replace the method name and that will implement the interface. And then we'll do the same with SMS class. And again, we'll just replace the method name. So now each of those classes then, they implement the interface. They have a relatively straightforward method naming convention of send message. And what that means is that if we use the interface from the high level object, it doesn't need to know about the actual implementation of the lower level classes. And that's kind of the point. What it also means is that we can get rid of these constant newing ups. So what we would do in the real software world is we would have some sort of registration class somewhere that's responsible for making sure that dependency injection within all of this will work. So if we make sure that here we pass in a collection of iMessage, so we're going to use iCollection of type iMessage, and these are just going to be called messages. And then here what we'll have is we'll have the same collection, but we'll have it as a private internal there. And then it means we can get rid of these and we can get rid of the private SMS there. So now what we're saying is we're going to take in a collection of these interfaces. And then how do we call the messages below that? Well, quite simply, this send notification becomes a loop. So we can say for each message in messages. And then because we're now relying solely on the contract that the interface provides, we just go message.sendMessage. So at the point where we call the constructor, we can pass in one implementation, we can pass in 10 implementations. You know, there might be 3 or 4 emails, there might be 6 or 7 SMSs, whatever. And it will just loop through and it will call send message. We don't need to rely on any instantiation of classes that we don't want to be tightly coupled to. And as you can see, what we also do then is we remove the tight coupling between the classes as well, which obeys the solid principles. Okay, so that's pretty much it in short for dependency inversion. But let's have a little think about some of the hazards and the benefits that this presents, because it looks relatively straightforward, but is it always a good thing to do? And I suppose in short, no, it's not necessary. And I think that's one of the things that you need to understand, is that sometimes something like this can introduce unnecessary complexity. And I think, like with all other coding, you should only ever really implement what is necessary. If you find yourself with, you know, let's say you had email, you had SMS, and you had a number of other different notifications, you could leave it this way and have them all implementing from iMessage, or at that point you could say, okay, well, are we introducing quite a lot of complexity here with lots of different classes inheriting from iMessage? Does that need to be split out? Does there need to be some other sort of controls there? Maybe, you know, a notification class then needs to be split out or whatever. But in terms of those potential hazards, the complexity is probably really the only one that I can foresee you having with this kind of pattern. And in actual fact, I think that overall the benefits of dependency inversion outweigh the potential complexities. So benefits wise, it removes a lot of dependency in the code. So as you've seen through this very easy demonstration, we no longer need to new up classes. And that's the kind of thing that you want to look for removing. If you've got instantiation of classes within other classes and newing them up, that's probably a bad sign. At which point, ask yourself, can you do something like dependency inversion to remove that coupling between those classes? Because it doesn't need to be there. The other thing is that as part of open-close principle, it also offers you a very high level of extensibility and adaptation to your code. So in this instance, like I say, if we had another type of notification class that we wanted to implement, we could implement it very easily without needing to change any code here. We could put in another class that inherits from iMessage, and again, if you inject it into the notification class, it will loop through and it will send a message. It doesn't care about the low-level implementation of it. So there we go, that wraps it up. Really, really short video, dependency inversion, very straightforward principle. Hope you enjoyed it. As always, if you have enjoyed this content, please hit the like and subscribe and ring the bell for the notifications. In the coming weeks, there'll be a lot more stuff. We're going to start looking at different .NET design patterns. We're going to be doing some personal projects in there, like how to write a Discord bot using Discord.NET wrappers. So there's some really interesting stuff, and I'd be really pleased if you guys could come along and join me. So thank you very much for watching, and until next time, goodbye.